everyone, welcome back to another question show. Your questions, my answers. As always, wherever you are on my channel, if a question pops into your brain, just write it down and I will gather a bunch of them up and I will answer them here. All right, let's get into it. Deezazazy. What would happen if Elon Musk went bankrupt now and SpaceX failed? Could another company take its place? What about all of the things that they've patented? Would Merlin Raptor engines simply be unavailable? Keep in mind first that Elon Musk and SpaceX are two different things, right? SpaceX is an enormous company with lots of people, and Glenn Shotwell is running SpaceX, so it's its own organization. Elon Musk could go bankrupt and that wouldn't necessarily affect SpaceX because it's a private company. That said, SpaceX could go out of business. I mean, rocket companies are known for going out of business, but I think that SpaceX has already really given its greatest gift to human spaceflight. They have demonstrated that the laws of physics allow a rocket to take off, to separate, for the first stage to land back on Earth, for it to be refueled and reused. And now the latest generation, the Block 5 of the Falcon 9, is demonstrating that the amount that you're going to have to refurbish is very little. You can refuel, they can go very quickly. They are moving into this point to see that rockets are really going to become reusable very rapidly. So I think that is the greatest gift. Now the big question, the big challenge that SpaceX is going after is the BFR, this idea that you can have both the top and bottom stage of your rocket be able to take off. Both are reusable, both are refuelable. This is the big question, and this is that next level gift that hasn't been provided to humankind yet. If the BFR actually does fly test and is successful, then I think that no other development by SpaceX would be necessary, and you would end up with just this demonstration of what is possible. But at the same time, if SpaceX continues in business, then you're going to continue to get these innovations and these advancements. There's so many problems that need to be solved. And Musk and team, again, SpaceX's thousands of people, are really good at going back to sort of base principles and then building up a solution from the challenge that they face. Now, if they go out of business, of course, there is another entire enormous competitor that's waiting in the wings, which is Blue Origin, run by the richest person on Earth, Jeff Bezos. He has been spending, and his company's been spending, a ton of money to get their own reusable rocket system off the ground, and literally. And right now they've only done the New Shepard, but they're working on the New Glenn and other rockets as well. So you're going to see a true race for the privatization of space with these reusable rockets, and this race has begun now, and even if SpaceX is taken out of the running, other companies now know this is possible. The Russians have announced that they're going to be launching their own reusable rockets. The Chinese are working on this technology as well. So I think within a few years, a few decades, it's going to seem ridiculous to launch a large payload into space and not use a reusable rocket. So thank you, SpaceX. Stone Camus. Are there any future space probe missions planned to go out in search of the possible Planet 9 and if make a flyby or go into orbit, or the probes already far out in the solar system like New Horizons going to do the job themselves? Or are we going to wait for ground-based telescopes or current space probes like New Horizons to confirm their existence and then launch a future mission? The outer solar system is really, really big, and it's hard to get across just how enormous that region of the solar system is. And so the spacecraft that are already out there, the Voyagers, New Horizon, they've actually got very small telescopes and are not well positioned to be able to find objects that are already out in the outer solar system. That's going to be the work that's going to be happening from ground-based telescopes and space-based telescopes here on Earth, especially the ground ones. There's one telescope that's coming in the next couple of years called the Large Synoptic Survey Telescope. And this is going to be this telescope, very large, very fast. It's going to be observing the entire sky every couple of days that it can see. And then astronomers are going to be combing through that data to find anything that's moving. And that's probably going to be the instrument that's going to find Planet 9. Once it does, then the question is, do you want to send a spacecraft to explore it more closely. And I'm sure the team that worked on New Horizons would love to send a spacecraft to even farther out into the Kuiper Belt. So first, ground or space-based telescope here on Earth is going to find it, and then people are going to decide if they want to send a mission to it. New Horizons went to Pluto. Now it's on to this other target, but it only has a little bit amount of fuel to be able to make any final course corrections. So whatever is deeper, farther out from where New Horizons already is, has got to be within this very specific cone of what it can reach. It's going to be able to make some final course correction after going to Ultima Thule on New Year's Day 2019, and then maybe there's going to be some other Kuiper Belt after that, and then it'll be out of fuel and really won't be able to make any more course corrections. And the outer solar system is so big, so just because you're out in the outer solar system doesn't mean you're anywhere near where Planet 9 is. It could be on the other side of the solar system. Silt. Any good alternative terms for dark energy and dark matter? I find those names incomplete and misleading. I totally agree with you. I think that the terms dark matter and dark energy are one of the reasons why people are so skeptical of it, because it's like this placeholder that astronomers use to say, like, we don't know what this thing is, and until then, we're just going to give it this placeholder name. And it's not very descriptive of what they are. They are mysteries, they are unknowns, they are unfolding as people find out more information about them, and it would be great to have a better term. So please, in the comments, let's hear some better suggestions for dark matter and dark energy, and then I will use my influence to turn the tide and try to convince people to use these two terms. So hit me with some ideas in the comments. Jim Becker. Space, the new workplace, will soon be available for a lot of young people who are already born. With that in mind, what do you think the common worker in outer space will be like? What will they study in school in order to be qualified for the mining and construction jobs in outer space, and not the flashy jobs just like the common worker? The thing about space is that it makes every job about 1,000 times more complicated, stressful, exhausting, and dangerous. One of my favorite interviews was with Mike Massimino, who was the repair person, right? The engineer who helped repair the Hubble Space Telescope. And when you think about what he was really doing, he was screwing off panels, he was putting in new electronics, he was pulling out parts, he was putting in new gyroscopes, as well as the rest of his team. And yet, it was in space, in microgravity, working under these incredible temperature and pressure constraints, where everything that you could do with these gloves that were really awful to work with, that everything that they could do was much, much harder. And so I think that the kind of people, it's not necessarily about training, although training is going to be important. It's about, are you willing to suffer for long periods of time to do meaningful work in a place that is really difficult? And that is, do you have grit, right? That is, I think, going to be one of the top indicators for astronauts into the future, no matter what the job is. Imagine if you're like a medic, right? You're there to help patch up astronauts that hurt themselves. You're going to have to be a medic in space, having to work in zero gravity to understand all of the difficulties. Imagine you're an astrobiologist. Imagine you're a geologist. Imagine you're a construction worker. These are all, the learning to do the skill part is the easy part. It's going to be the having the personality and having the physical endurance to be able to do this stuff in space that I think is going to really be the greatest challenge. And so I think that if you ever get a chance to meet astronauts, they are amazing. They are well educated, they are brave, a lot of the times they're test pilots, but the part that always strikes me is that they just seem like really genuinely good human beings, like the kind of people that you would want to work with day in and day out and depend on for your safety and survival. And so I think that is the thing. Learning teamwork, learning to work with other people, learning to work even when everything is really hard and you really don't want to be out there in that kind of pressure and temperature and stress. So that's what I think. Grit, working in bad situations, and you can practice that all the time here on planet Earth. Get to it. Ken Solch. Oh God, seriously? Now I have to unsubscribe because you've proven yourself to be clueless. The EBE aliens have been here for thousands of years, are here now, and will be here until we make this planet too radioactive to live here. I feel sad you do not get it. I've studied the topic for 60 years now. I'm sorry to see you go. Marconi Aziz. Fraser, I was wondering, do you think galaxies have their own versions of Kuiper Belt or Oort clouds in their outermost regions? And so, do you think this material is or can be part of the missing matter, dark matter, that give galaxies their rotational speeds? Couple of questions there. One, do we think that planetary systems have other Oort clouds like the solar system? That's of course that cloud of comets that are surrounding the solar system. I don't think they've been detected. I mean, we haven't detected the Oort cloud around the solar system. We just know because there are comets falling into them. But other Kuiper belts have been discovered around other solar systems, which is really cool when you think about it. They've actually detected rings of comets around other planetary systems. Would there be, so in other words, if there is a Kuiper belt, then there is ice in these outer solar systems. You would kind of think that there must be an Oort cloud. You would expect it's there. There's one piece of research that I just read that was really interesting, that it might be possible to see, to sense these Oort clouds in other solar systems by looking at their imprint in front of the cosmic microwave background radiation. This is this background that's around all in all directions of the sky, that moment that the light from the universe was finally able to escape out into space. And astronomers used it for everything, to find out how old the universe is, to find out how much dark matter there is. And now maybe they could use it to find Oort clouds around other planetary systems. Amazing. But is it dark matter? No. The thing is that dark matter seems to be like 10 times as much material as regular matter. And so if it was clouds of comet, ice out there, this is the kind of thing that astronomers would be able to detect. They've really, and I've got an episode coming out very shortly, but they've really narrowed down a lot of the characteristics of what dark matter has to be. And ice isn't one of them. So Oort clouds are cool. They provide some mass to a solar system, but they're not going to provide enough mass to be dark matter. Mark Sheeran. Hey Fraser, love everything you do. Realistically, when do you think man will walk on Mars? Oh, great question. 2037 is my guess when the first human being will set foot on the surface of Mars. And now I know that SpaceX says that they're going to be sending colonists to Mars within 2022, 2024. My feeling, and this is just my feeling, in watching space companies attempt dramatically new things, is that they take longer than anyone was expecting, and that there are unforeseen circumstances that happen. And so I can imagine that SpaceX and NASA, which are both in the plans of developing Mars exploration missions, both are going to see challenges that are going to push their timelines out. But I really do feel like SpaceX is serious. They want to do it. They're going to build the hardware, and they will eventually send at least explorers to the surface of Mars. But it feels to me like when they realize there's the problems with the radiation and spacesuits and toilets and just all the details about keeping a human being alive in a place that human beings were never meant to live, those are going to be the challenges that are going to hold up all the little pieces. So that's my feeling. 2037, I'm making my guess. 2037, human will walk on Mars. But I would love to be proven wrong, as long as it's safe and nobody dies. Hebrux Artman. Suppose two black holes are orbiting one another in such a way that their event horizons overlap. Which way would I fall if I entered that zone of overlapping? All right, I'm trying to imagine your scenario here. You've got two black holes. They're orbiting around a common center of gravity. They're orbiting around each other, and their event horizons are overlapping. And in this situation, once you get to this, they are spiraling in on each other, and they're going to merge. And this is how we saw the gravitational waves from black holes colliding into each other. So this situation probably isn't going to last for very long. But the reality is that what a black hole can do to you, it will do long before you get within the event horizon. There are the tidal forces that will tear you apart. There's the radiation streaming out, the gamma radiation coming from the region around the black hole. It's a very bad place to be. But So what's going to happen, right, is that as you get closer to these black holes that are going around each other, is their tidal forces are going to tear you apart, and they're going to separately, whichever one was able to get you a little bit closer, that's the event horizon that you're going to fall into, and then those two black holes are going to spiral into each other and turn into one black hole, and now you'll have one nice big event horizon. So for that brief moment, as the black holes are just slightly overlapping, they're going to be tearing you apart and eating you separately, and then bring those separate parts of you together forever. Well, until they evaporate. Kikinu. Hey Fraser, in all the best fiction about manned missions to Mars, The Martian, Race to Mars, National Geographic series, the crew size is 6 people, 3 men, 3 women. Do you find this to be optimal as well? And how do you think they would deal with backup crew in case one of the 6 can't go because of illness or whatever? That'd be kind of tough to train for 5 to 10 years only not to go in the end. Thanks. The most optimal mission to send humans to Mars is to send one person on a one-way journey to Mars and then leave them on Mars. That's the cheapest way to do it. One-way mission, you don't have to return people back to Earth. That could be done tomorrow, although who knows how long the person would survive on the surface of Mars. So there have been various sizes, and this is an argument that NASA has, and I've seen anywhere from 2 to 4 to 6 people. I know the SpaceX would like to eventually get to 100. And there are upsides and downsides. The more people that you send, the more people that you have to be able to deal with an emergency. You've got more cross-training. People can take over from other people if there's problems. It's very hard to treat yourself if you fall unconscious without a doctor. So the 6 sounds fine, but even that is a tremendous amount of life support equipment for a long distance journey. And this is one of the reasons, just to go back, that I'm such a fan of doing more tests here around Earth. Let's find out. Let's send a mission and see what it's like to keep 2 human beings in deep space for a year. Let's find out what happens with 4 people, with 6 people. Let's learn what are all the ways that everything goes wrong so that we've got a much better sense of what's going to be the right mission size to go to Mars. But if you want to really cut down your prices, just send one person and don't let them come home. That's cheap. GC Jerry USC. What gets me is the arrogance of astronomers and scientists who don't even know what 85 to 90% of the universe is, but continue to tell us how it began and how it will end. They used to say the universe would end in a big crunch. Oops, wrong. The whole point of science is that it takes some series of observations and then tries to establish some underlying mechanism, to understand what is the mechanism that is going on to explain those observations. We see galaxies speeding away from us in all directions, and so astronomers have come up with this theory, the Big Bang, to try and understand and try to say, okay, all of these galaxies are moving away from us in all directions. Therefore, in the past, those galaxies were closer together. And at some point in the past, those galaxies were all together in one small region of space. And then they say, okay, great. So if that's our theory, let's come up with other evidence, other predictions that we would see in the universe that would provide more proof that that theory that we've come up with, that the universe is expanding, is possibly or probably the correct one. And so astronomers have made other predictions. They found the cosmic microwave background radiation. They found the amounts of hydrogen and helium and then lithium and other heavier elements. And there have been a bunch of other predictions that the Big Bang Theory has made to say, okay, yeah, indeed, the observations seem to say that a long time ago, 13.8 billion years ago, the universe was a lot more dense than it is today. But that theory could be totally wrong, right? And the great thing about science is that someone can come along and they can say, oh, I've made a better prediction. I've found a way to explain the universe in a way that your current methods don't work. And it not only explains all of the stuff that we see and all of those observations, but it makes some new predictions that if you go out and you see, then you're going to find that indeed this is true. It explains other mysteries that have been cropping up that haven't been found. And in the Big Bang, there are a bunch of mysteries. Why is the universe so smooth? Why aren't there monopoles in the universe? And this is why inflation was developed, because actually there's a bunch of problems with the Big Bang. And that's how science works. And to use an analogy, right? When you're coding software on your computer and you find a bug, you have your first idea of what that bug might be. And then you do some tests on your software to see if that's indeed the bug. And if it's not the bug, then you rule that bug out. And now you try another bug, and then you try another method, another fix, and another fix. And eventually, your model of what's causing this problem in your computer program turns out to be the correct one, and you fix the software so that the bug goes away. And that is essentially what the scientific process is. And when you look at these ideas like the Big Bang, theory of evolution, theory of gravity, they have stood the test of time because they have plenty of evidence to support their current theory. They make predictions, the observations match, and people have been unable to come up with better theories that match the observations that have been seen so far. So I wouldn't call it, what was the term you used? Arrogant. I wouldn't call it arrogant. I would call it painstaking and laborious and willing to admit when the theory and the direction that you've gone down was wrong and go back. There's nothing scientists like better than to be proven wrong, because then they understand more about the universe than they did before. Hero323. Hey Fraser, given the age of the universe, what is your stance on the Fermi Paradox and advanced civilization somewhere in the Milky Way? I've done a bunch of videos about the Fermi Paradox, but they were a long time ago, and I know other people have been doing lots of great work on the Fermi Paradox. The Fermi Paradox, this idea that the universe is big and old, that Earth is not the first planet that has existed in the solar system. In fact, we arrived very late to the scene. The fact that there's no reason under the laws of physics why intelligent civilizations couldn't colonize their entire Milky Way. I find that idea really troubling. I find this fact that we seem to live in this universe and we see no evidence whatsoever of other intelligent civilizations, and yet we're on our way to creating an intelligent civilization, we hope, that will eventually be able to colonize or at least explore the Milky Way. It is this really troubling idea in my brain, and I really feel like anybody who has this just, oh, I get it, it's just because they don't want to communicate, or the distances are really far, or they all just go to sleep, or maybe we're in a zoo, or whatever, right? That each one of those ideas falls apart. And so I don't want to go into a full video on the Fermi Paradox here. Like I said, I've done a bunch of them in the past, but I really feel like anybody who feels like they've solved the Fermi Paradox, who understands the Fermi Paradox, hasn't spent enough time thinking about the Fermi Paradox. And it's only when you get to this point where it really freaks you out, that's when you're starting to really understand it, or at least understand the enormousness of the challenge. One of the most amazing things, and I got this in a video interview that I did with Brad Peterson from LUVOIR about 3 weeks ago, was he said that the LUVOIR telescope, one of the things that it's going to do is it's going to be able to look out into the space around the Earth with such precision and to be able to analyze the planets around us that it will be able to answer with a 90% certainty whether or not we're alone in the universe, which is just a mind-bending concept. So what's wonderful about this as well is that this is still a practical question. Astronomers are pushing out into the universe. They're looking with more sensitivity at the other worlds that surround us, and they will be able to find out if any one of them have life. And if you get to this point where LUVOIR is tapped out, it has examined every single planet that it can, and it hasn't found life, then we're almost certainly alone in the universe, which is a really, again, a very troubling concept. All right, thanks everyone, that was awesome. I really enjoy it. As always, wherever you are on my channel, if a question pops in your brain, just type it down in the YouTube comments. I'll gather a bunch of them up and I will answer them here. And I'll see you next week.